Hi everyone, welcome to my channel. Today's video is question number 4, 2011. Let's read the question first. Let Fn represent the number of ways that a positive integer n can be written as the sum of positive odd integers. For example, f5 equals to 3, since there are 3 ways to write 5 equals to 1 plus 1 plus 1 plus 1 plus 1. 5 equals to 1 plus 1 plus 3. 5 equals to 3. Yeah, the sum of positive odd integers. Positive odd integers. There are positive odd integers. They cannot be 2, 4 because they are even. Yeah. So f6 equals to 4 since 6 equals to 1 plus 1 plus 1 plus 1 plus 1 plus 1 equals to 1 plus 1 plus 1 plus 3 equals to 3 plus 3 equals to 1 plus 5. Okay, so f6 is 4 because there are 4 ways to written 6 as the sum of positive odd integers. Let's find f8 and list all the ways that 8 can be written as the sum of positive odd integers. Yeah, 8 equals to 1 plus 1, 1 plus 1. Yeah, and equals to 5 ones, 1, 3, and 2 ones, 2, 3, and 3 ones, 1, 5, and 3 plus 5, and 1 plus 7. That would be 8, 1, 2, 3, 4, 5, 6. It will be 6. So f8 is 6. All right. Let's see part B. Prove that fn plus 1 is greater than fn for all integers n greater than 3. Okay, we already know that f6 is 4, f5 is 3. So f4, let's try f4. 4 equals to 1 plus 1 plus 1 plus 1 and equals to 1 plus 3. So f4 is 2. So now f4 is less than f5, less than f6. So far, okay. So let's assume that n can be represented as a1 plus a2 plus a3 plus etc. ak. ai is odd. I is greater than 1 and okay. Let's assume n plus 1 is odd. So n plus 1 equals to a1 plus a2 plus a3 plus etc. plus ak plus 1. Just the same numbers of ways, and we will have one more because a plus n plus 1 is odd. So we have one more, n plus 1 equals to n plus 1, like 5 equals to 5, 7 equals to 7. Yeah, so we explain it more specifically since 4 equals to 1 plus 1 plus 1 plus 1 equals to 1 plus 3. So 5, we add 1 on both these. So this first one becomes to add 1 and the second one will be 1. So they already have and the last one is 5 equals to 5. So this one is new. So they are the same ways, and this one is new, so it's greater. f5 is greater than f4, and for all the n plus 1 is odd, this will be satisfied. We can use this way. So fn plus 1 greater than fn. Okay, so if n plus 1 is even, and n can be represented like a1 plus a2 plus a3 and plus ak, yeah, the same thing. N plus 1 can be represented like a1, a2, a3, ak plus 1. So just the same numbers of the ways. And we can discuss, is there anything new? N equals to 3k. N equals to 3k. So n can be represented like 3 plus 3 and plus 3 and plus 3, all the 3's, because n equals to 3k. So there are all 3's. And n plus 1 will be 1 plus 3 plus 3. Since n is greater than 6, so there are at least 2 3's. Because we already discussed everything here, so n will be greater than 6. Greater equal than 6. Yeah, so we have at least 2 3 here. So 1 plus 3 plus 3 will be 7. So n plus 1 will be 7 plus 3, 3, 3, 3, all the 3's. Yeah, there are, which is new in fn plus 1, because there's no 1. There's no 1. Understand? It's a new one, because the 7 is composed by the new 1 plus n plus 1. Then this one is new, so this 7 is new. Okay, let's discuss about n equals to 3k plus 1, which k is greater than 2. So n will be like this, 1 plus 3 plus 3 plus 3, all the way 3's. N plus 1 will be 1 plus 1 plus 3 plus 3, all the 3's. So n plus 1 and this 1, 1, 3, these 3 things, we can add them up as a 5. Yeah, these 3 things, we can add them up as a 5. I think this one is new, so this 5 is new, so the total 1, 5 plus 3, 3, 3, 3, all the way 3, which is new in f n plus 1. Yeah, because there's new one, yeah, it's a new one. So let's discuss about the third cases, n equals to 3k plus 2. So n will be like this, 1 plus 1 plus 3 plus 3, all the way 3, and n plus 1 will be 1 plus 1, 1 plus, and plus 3, all the way like that, and n plus 1, and these 3 ones will become a new 3, since this one is new, so this 3 is new, which is new in fn plus 1. Okay, so far we discussed all the cases about n, odd, even, yeah. So we are down here, so that fn plus 1 is greater than fn. Okay, let's see part C. Prove that f2n is greater than 2fn for all integers n greater than 3. Okay, let's try. We already know that f8 is 6. f8 is 6. Yeah, part A. It's the answer of part A. And f4 is 2. And 2 times 2 is 4. So 8 is greater than 4. So let's see f5. f5 equals 3 since 5 equals to 1 plus, yeah. And we can generate 10. 10 is like this, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. So we use this first way written as the sum of the positive integers, and 1 plus 1 plus 1 plus 1 plus 1 plus 3, 1 plus 1 plus 5. So there will be 3, and we use 5. The last one, the last one, and 5 plus, yeah, there will be also 3, but you can see it's an overlap here. 1 plus 1 plus 1 plus 1 plus 5, 5 plus 1 plus 1 plus 1. It's an overlap, so we minus 1 here. But we can have 2 more because there are 2 odd integers between 5 and 10. There are 7 and 9, which these 2 won't be in F5. Yeah, because 7 is greater than 5 and 9 is greater than 5. So these 2 are new in F10. So F10 will become F5 plus F5 minus 1 plus 2 and greater than. Since we also have 7 plus 1 plus 1 plus 1. To simplify the question, I don't want to write all the 7s here. So that is to say F10 is greater than 2 times F4. Okay, now let's try 6. 6 can be written like this. 1 plus 1 plus 1 plus 1 plus 1. 1 plus 1 plus 1 plus 3. 3 plus 3, 1 plus 5. There are 4 ways. So we try 12. Yeah, we use the first way plus all the ways in F6. The first way, all ones, and we use the last way, the biggest odd number. We use the last way, and we see there's only one overlap here. Yeah, but we have 3 more integers, odd integers, which are greater than 6 and less than 12. So it's 7, 9, 11. So we have 3 more. So F12 equals to F6. Yeah, here it's F6, here is F6, and we minus 1 overlap here. Oh, it's overlap, and we plus 3 more. Okay, it's not correct here. It will be greater than, because we have more like this. 7 plus 3 plus 1 plus 1, and 7 plus 1 plus 1 plus 1 plus 1 plus 1. Yeah. Yeah, so 12 equals to, yeah, the 6 ones plus every sum of every possible sum of 6. Yeah, so yeah, I used the square bracket to show the 6, to show the sum of 6, and we use 6 1 add like this, and we use the last one, the biggest odd number, which is 1 plus 5 like this, and we can see there's 1 overlap, so minus 1, but there are 3 odd numbers which is greater than 6 and less than 12. So these 3, it won't appear in the F6. It will only appear in F12. So these 3 are new. So that's F6 plus F6 minus 1 plus 3. So it's greater than 2F6. Okay, so we discussed 5 and 10, 6 and 12. So we can abstract it in a more general way. Let's assume A n is 1 1 plus 1 plus 1 plus 1. Yeah, it's the way to the sum of positive odd integers. They are all ones, and the Bn is the greatest odd if n is odd. So Bn equals to n, and Cn equals to n plus 1, even n if is Cn is n is even, so it's n minus 1 plus 1, n minus 1 plus 1. So A and B and Cn. So since n is greater than 5, there must be odd numbers di, yeah, which d is greater than n as less than to n. So there must be more than 2 di's. Yeah, I is greater than 1 or the group equal or greater than 2. So f2n has, yes, we use am plus odd fn possibilities, and we use bn plus odd fn possibilities. Yeah, and we know that there are only one overlap, so we minus 1, and 2n can be written as d1 plus something, or d2, and 2n can be written as d2 plus something. Okay, so at least we can get f2n is greater than fn plus fn minus 1 plus 2, which is greater than 2fn. Okay. So the Bn is the greatest odd. So it's the 5 case. It's the 5 case. So we have 5 plus 5, yeah. And the Cn is the 6 case because n is even. N is even, so we have the greatest odd number plus 1. So it's the 6 case. So Bn is the 5 case, Cn is the 6 case. And yeah. Or, sorry, I didn't write it very clearly here. So that will be or Cn plus Fn. Yeah, let me put it here like that. Or Cn plus all the Fn's. Okay. Okay, so that will be okay, so that will be more clear. Yeah. Okay. And now we are done. Thank you very much for watching. Remember, persistence is most valuable. Bye bye.